Welcome back. In this video, we are going to solve problem 14-10 that is taken from chapter number 14, Energy Methods, and book name is Mechanics of Material by R.C. Hibbeler. So statement is the shaft assembly is fixed at C. The hollow segment BC has inner radius 20 mm and outer radius of 40 mm, while solid segment AB has a radius of 20 mm. Determine the torsional strain energy stored in the shaft. The shaft is made up of 2040 T6 aluminum alloy. The coupling at B is rigid. So you can see this is shaft BC and this is shaft AB. The end C is fixed. There is a coupling between B and in shaft BC and AB, which is rigid. At point A, we have a clockwise torque of 30 Newton into meter. At coupling, we have a 60 Newton into meter clockwise torque of 60 Newton into meter, and this BC is hollow. Inner radius is given as 20 millimeter CI and C outer for BC is 40 millimeter, while solid segment AB has radius 20 millimeter. So you have to determine the torsional strain energy stored in this shaft. So let's start with the solution. As we know that strain energy due to this torsion is equal to sum of T square into L divided by AB. Why this formula? Because you can see we have two different sections, so where we will find this torque. So for this portion AB, this formula will become equal to UI due to torsional will be equal to TAB square into LAB divided by GJ. This is not AB, this is GJ. So GJ. So JAB. Material is same, only diameters are different. And this for segment BC, it will be TBC square into LBC divided by GJBC. Now, how we'll find torque AB? So we will cut this in segment AB. So I will write for segment AB. When you draw it, the free bar diagram will be like this. Clear? Here you have, this is the axis, for example x-axis. So at this is your point A. So here at A you have a clockwise torque of 30 Newton into meter. So in order to balance it, you have TAB is will be having TAB. In order to find TAB, we will apply equation. Sum of all moment about x-axis must be equal to 0 and counterclockwise taken as positive. So torque TAB, which is counterclockwise, and the other one which is minus 30, their sum must be equal to 0. So it means that TAB is equal to 30 Newton into meter. So this is the torque in internal torque in this segment AB. Now we will apply for we will find for the segment BC. For segment BC, I will cut it along any length of BC and draw the free body diagram. So it will be like this. This is BC. Clear? There is a coupling over here, and then we have another segment which is segment AB. Okay. At this point, this is point A, where you can see you have clockwise torque of 30 Newton into meter. This is coupling there at our point B. So at point B, we have a torque of 60 Newton into meter clockwise. So this is the axis. Clear? So the net torque will be equal to counterclockwise, and that will be TBC. So how you will find this TBC? By using this equation of equilibrium. Now we'll apply TBC is counterclockwise, so it will be positive. Minus 60 minus 30 will be equal to 0. So from here TBC will be equal to 90 Newton into meter. Now you have TAB and TBC. Length of AB is given as 600 millimeter, which is equal to 0.6 meter. There 0.6 meter. Length of BC is also again 600 millimeter. That will be equal to 0.6 meter. G, we will find G by using mechanical property table. So for T 2014 T6 aluminum alloy, we will find G. So G for this will be equal to, again, you will go to the property table. Again, we have to find this table. You can see this is the table, and here from this T 2014 T6. So G is 27 gigapascal. Clear? So note down it, 27 gigapascal. So G is 27 gigapascal, or that is equal to 27 into 10 raised to the power 9 Pascal. Now what about JAB and JBC? So JAB is for solid segment. For solid segment, JAB is equal to pi by 2 CAB power 4. CAB is given as 20 millimeter. So in meter, it will be equal to pi by 2, 0.02 power 4. And that will give you 80 into 10 raised to the power minus 9 pi, and unit will be meter power 4. Okay, now for hollow segment BC, hollow segment BC, this JBC will be equal to pi by 2 C outer of AB, BC, not AB, BC power 4 minus C inner of BC power 4. Okay, so you can put the value pi by 2. C outer was 40 millimeter. Clear? Let me check it. That is, C outer is 40 and C inner is 20. Okay, so 40 is 0.04 meter. Clear? Power 4 minus C inner, it was 20, and that 20 millimeter, which is 0.02 meter, power 4. That will be polar moment of inertia for this hollow segment BC. Again, when you solve this, you will get 1200 into 10 raised to the power minus 9 pi, and unit will be meter power 4. That will be JBC. Now you have all these values, you can just put it in this formula. Clear? Which was strain energy due to torsion will be equal to TAB square into LAB divided by JAB plus T square BC LBC divided by JBC. So put the value. TAB is 30 Newton meter. So 30 square into length is 0.6 divided by G is 27 gigapascal, and J is 80 into 10 raised to the power minus 9 times pi, plus TBC. TBC you can see 90. So 90 square multiplied by length is 0.6 divided by G is 27 into 10 raised to the power 9, and J is 1200 into 10 raised to the power minus 9 times pi. That will give you strain energy due to torsion. And when you solve this, you will get 0.06379 joules. Or strain energy due to torsion will be equal to 0.0638 joule. So this is the amount of strain energy that will be stored in the shaft due to the applied torque. And that was all about this problem 14-10. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also share my videos with your friends and help me in growing my channel further. Thank you for watching.